In this video, I'm going to show you how to simplify a rational expression using the method of clearing the fractions. So first, let's recall what does it mean to simplify a rational expression. It means two things. First, we shouldn't have fractions in the numerator and the denominator. And then we have to make sure that the rational expression is written in reduced form. Here we can easily see that the first condition is violated. We do have fractions in the numerator and the denominator. So how do we get rid of those fractions? How do we fix the issue with the first condition? We use the method called clear the fractions. In this method, we consider all the denominators. So in this case, all the denominators are here. It's x minus 1 and x plus 1. And we're going to find the least common multiple of all of these denominators. Since they have nothing in common, no common factors, so the least common multiple will be simply the product of the two. And now what we're going to do is we're going to take our fraction and we're going to multiply the numerator and the denominator by that LCM that we just found earlier. So technically I'm not changing anything about this fraction other than its appearance. Basically just writing another equivalent fraction, because as we know, it is okay to take your fraction and multiply everything by the same number. It's also okay to divide by the same number. So nothing happened here, and now I'm going to take this and distribute it inside of the parentheses, and then I'm going to take this and distribute it inside of the parentheses. If you do it carefully, then you would quickly see what happens after you distribute it. Every fraction that you obtain is not in simple form, because the numerator and the denominator have something in common. So in this fraction we have x minus 1, x minus 1, so we can reduce it. In this fraction we have x plus 1, x plus 1. So every fraction now, after it's reduced, it's not a fraction anymore, it's just a simple linear expression in this case. In general it could be something else, but what's important is that we don't have fractions anymore in the numerator and the denominator. So we're fixing the first condition. So we fixed the first issue, and to make sure or to check whether it is in the reduced form or not, we now have to factor the numerator and denominator and see if they have anything in common. So before I actually distribute everything, I actually noticed something here. If you just look at these two terms, they both have x plus 1. So let's try and factor this, see what happens. So if you factor x plus 1, what's left is 1 plus x minus 1. In the denominator we can factor out x minus 1. So you factor out x minus 1, what's left is 1 minus x plus 1. Simplifying everything will give us the following result. And here we can see that this can be simplified further by reducing everything by x. So the final answer is x plus 1 over, let's move the negative to the front. Why can we do that? Because if you have a fraction like this with a negative here, that negative can be moved around and the value of the fraction will not change. So here I took this negative 1 and moved it to the front, and this is my answer. Now, if you couldn't factor it right away, then alternatively you would probably end up doing this. So let's put or, So alternatively, you could have just distribute everything. Notice here that x minus 1, x plus 1 is just x squared minus 1. And 1 would cancel. 1 would cancel here too. And you would factor out x here. So it doesn't matter, one way or another, you would arrive to the same simplest form. So hopefully you can see here that this is exactly the same as this. So this is how we simplify a rational expression.